All right, we're back and we are going to talk about envelopes and LFOs. So in the last little part, we talked about oscillators and filters and amplifiers. Not so much amplifiers, but a little bit about amplifiers. And this part, we are going to talk about envelopes and LFOs. Envelopes and LFOs are pretty cool things. So basically, it's like this. Boop, ba-doop, ba-doop. Okay. So, let's go back to this screen, right? Oh, there. So you have your oscillator that makes the sound, and the sound goes into the filter, and then the filter subtracts harmonic frequencies out of the sound, and then your amplifier amplifies the sound. Well, that's all well and good, but we also have these things in here called modifiers that allow us to modify the sound, but they don't actually touch the sound. So the oscillator and the filter are touching the sound. The oscillator makes the sound, the filter shapes the frequencies of the sound, so it's actually touching the sound. But then you have these modifiers that allow us to work without actually touching the sound. So that's what it's saying right here. They do not touch the sound. They modulate parameters associated with the sound with the oscillator, amp, or filter to change the sound. So they modify, they modulate something. Sorry, I was saying modifiers earlier. I meant to say modulators. They modulate stuff. So they do not touch the sound. So what you'll see these days is in some analog synthesizers, the analog, the sound chain, the signal flow is completely analog, but the envelopes and the LFOs might be digital. And you can do some really cool stuff with digital envelopes or digital LFOs that you can't do as easily with analog LFOs or envelopes. But the sound is still analog. So those are still analog synthesizers. They just have digital components. So this here, if you look at this illustration that I've drawn, you have your oscillator, the sound goes into the filter, goes into the amplifier. And then you have the LFO or the envelope down there sitting down beneath it that are going to adjust certain parameters. And some of the parameters they can adjust. Let's go ahead and let's look in here. So in this case, this one has an oscillator, LFO. It has one LFO for modulation stuff, and then it has two envelopes. And the two envelopes can shape our filter or our loudness. So let's just start with the loudness here. And I'm going to go ahead and there we go. I'm going to use that sound right there. And I'm going to use the loudness contour here. Zoom in on that. So if I want my sound right now, my sustain level here is all the way up, and I have an attack time and I have a decay time. So when I let go of the sound, if you look at my hand, with the decay time up, I let go, and it takes a while for the sound to die back to silence. Okay. Now, if I hold it down, so I've got this, if I let go, it plays it and it kind of dies out slowly. But if I hold it down, it just plays and plays and plays until I actually let go. Well, if I turn the sustain level down, the sustain level is what's saying how loud it's going to be as I hold it. So if I turn my sustain level down, it doesn't matter how long I hold the note for. It's just going to play and then die off. Okay. So That's your loudness contour. Now, if I wanted to start off slow, get loud, let's see here. Just get closer to the transient, yep. What are you talking about? Get closer to the transient. The release. So if I wanted to start off slower and grow louder, what I do is I set my attack time to a higher number. So now it sounds more like a violin type of thing. The release brings it closer to the heart. Yeah, so I mean, basically, if you turn the sustain level down, it's going to make it so it doesn't hold the note out at all if you're holding it down. That's what the sustain is. The sustain is like when you're holding the note down with the keyboard, it's going to keep playing it. But if you turn the sustain off or down, it's not going to hold it out as you play it. That's what sustain does. So, and I can make sounds like this by adjusting my attack time and my decay time. Now let's take a listen to, great. Let's take a listen to what the filter envelope can do. The filter envelope is exactly the same as my loudness, and they call it contour here, but it's an envelope. That's what the modern name is for it. The reason why they're calling it contour here on the screen is because that's what Moog called it on the original keyboard. But since then, the name has changed. So let's go over here and let's say the contour amount. Now, what's interesting about this is the contour amount is showing me how much it's going to adjust this knob right here. So if I turn this down and I adjust the contour amount up, basically when I turn this down, so here, let me just turn this down. See how the sound is dark. If I turn this up, right, it makes it brighter. But if I wanted to now, if I want to have it so it does stuff automatically, I can go over here to my contour amount. I turn this up. And now it follows my other envelope. And now the sound sounds a lot more beautiful. And a lot smoother. Right? And if we added some effects to this, let's add a little delay. Sounds a lot better, right? Sounds pretty cool. Neat. Yeah, sounds good. Very film scory. Yeah. Okay. So, turn those off. That's what you can do with your envelope. And let's just take a look at the notes for the envelope. So the envelope, a normal envelope type is ADSR, which you've probably heard people talk about before, ADSR. That stands for attack, decay, sustain, and release. ADSR is the envelope. Now the two of these, attack and decay, are a time. attack and decay and sustain is a level and then release. So here's how it would look on as if you draw it out. So imagine this. So a sound, basically it starts at nothing, which let's call that 0%. It's just silence. And then it goes up to the max, which is 100%. Okay? And there's the space between those. Let's go over here. Wait, let's go over here. This side. Okay? So you got 0 and 100%. And what happens is that 100% is set by the amplifier knob, the knob on the amplifier, like the output or something like that. Okay? So what we want to do is the sound wants to go to 100%, but how long it takes to get to 100%. When I press the key down, the length of time it takes to get to 100%, that's my attack time. So that's the timing of the attack, is how long it takes to get from 0% to 100%. Okay? I'll answer that question in a little bit, Jerry. Okay? Then, as I'm holding the note down, what level does that sound sustain at? Like if I'm holding the keyboard down, what level does it stay at? That's my sustain level. Okay? That's my sustain level. So time it takes to get from 0 to 100% is my attack time, and then my sustain level is somewhere in there, or it's at 100%, or it's somewhere in the middle there. Okay? And as we can see from our diagram here, this I've got it right here, like somewhere like around 60%. So it takes, let's say it takes 1 second to get to 100%, and then the time it takes to get to my sustain level is the decay time, normally what we call the decay time. And that, let's say it takes another second to get there. So 1 second, 1 second. And now we're just holding the note down on our keyboard, and it's the sustain level. Then when I let go, right, remember, here's our timing of things. When I let go, it has to go back down to silence because it wants to go back home. Home is silence. So it wants to go back home. So we get to silence. How long does it take to go to silence? So when I let go of the key on my keyboard, the time it takes for the sound to come all the way down to silence, that is our release time. And that's right over here. So attack and decay are timing, and release is timing, but sustain is a level. Whenever I talk about this, I always think about Happy Gilmore when they're talking about you got to get the ball to its home. Get the ball to its home. The ball wants to go home. The sound wants to go home. The sound wants to go home, all right? It's not too good for its home. It wants to go home. That's what's happening here. The sound is going to go back home, and that's the release time. So let's take a look at a slightly different synthesizer. We're going to go back. We're going to close this one down because this one's old school, and it uses slightly different terminology. Let's go over here and look at the analog synth again. We're going to go down here, and I'm going to zoom in on that for y'all. And I'm going to put this back on low pass. So here we go. Here's this. Just make sure y'all can I just knocked it. Okay, yeah, we're good. So now, I'm going to go, whoops, sorry. Making y'all dizzy by zooming in and out so much. There we go. Okay. So we have this here. Change my... There we go. Make that bigger, the pulse width. Make it at 100%. Oh, yeah. That sounds nice. Okay, so we're going to go over here to our amp. And you can see it better on here. The attack time is this. I'm going to put it linear. All right, and the release time is over here. So you can see what happens when I take my finger away. It takes a while for the sound to go back down to 0. Now, if I want to start fast, now what I'm going to do is I'm going to change my sustain to be a different level. And then this is going to sound like the sound has a point on it. And you can hear how it's got like a point on the beginning of it. I put my release up. There we go. Okay, and that's on our amplifier. So you can see the amplifier is here. And then we can see the level. This is like our 100% right here. The 100% is this level right here. And there we go. Now, if I want to make it so it's bright in the beginning, but gets darker quickly, it just got like a little point on the beginning, I can do that by adjusting my filter envelope. And the filter envelope is right over here under the filter section. It has its own envelope, and most synthesizers do have their own envelope for the filter. And what I'm going to do is I'm going to adjust this and make it so it comes down, sustain like this. And I'm going to pull the filter frequency down because you notice you're not hearing very much. It's not really doing much. So I'm going to turn this down. But before I do that, I'm going to put this filter envelope at 4. And let's turn this down now. Let's turn this up. And here it's got that pop on the beginning. I'm going to go ahead and record this. I am absolutely in the middle of explaining what envelopes do. I'm right in the middle of it. So let me continue with this because we're still talking about envelopes. We're still talking about envelopes. But actually the question, Magnolia, that you might be asking is not it's not what envelopes do, it's more like maybe how they work. And that might be the actual question, what you mean. And I will go back and explain that. Just give me a second here. Let me just record something in. All right, cool. So I got that there, duplicate that. So I'm going to make a little bit making this here. Yeah. Okay. Well, we're gonna come back and talk about that. So here, so some of those notes are fast and some of them are slow. And let me just make sure they're all, yeah, here, let's just change all this to legato so they all connect together. So they all connect. I'm gonna crop it off. That. Yeah, cool. Okay. Now let's go take a look at our synth down here. And first of all, I'm going to put that all the way up. I'm going to go over to my amplifier, and down here in the amplifier, we're in the envelope. Now, just like to review this real quick, so hopefully this will, you can understand this more in depth. The envelope, what I'm basically doing with the envelope is I'm shaping the amplifier here. So if I put this all the way up, my sustain is all the way up. That means that when I'm holding the note down, it's just going to be loud. Hear that, right? So it's just loud the whole time. The whole time the note is being held down, it's just loud. But if I want it to be quieter when it holds it down, you can hear that it's still sustaining through the note, but it's just softer. If I don't want it to sustain at all, if I just want it to just play, I just turn the sustain all the way down. Because if we look at this screen here, the sustain is as we're holding the note out. So see this here, the note is being held out, note on and note off. I'm holding the note here, that's my sustain. So if I don't want to hear anything in there, I'm going to turn my sustain all the way down to 0. Right here. If I want to hear the sustain, but this has like a point on the beginning because you can see right here, there's like a point. If I don't want that point, so you're like designing what's inside the envelope of settings for the sound. Yeah, I mean, what I'm doing is I'm designing how loud the sound is over time. If I want the sound to be loud the whole time, I'm making it loud the whole time. Or if I want it to be quiet, or if I want it to start quiet and get loud suddenly, or quiet, slowly, or whatever, that's what the envelope in this case is doing. But envelopes can control a lot of different things. And so what I'm going to show you now is the envelope controlling the filter. So that's the envelope is controlling the amplifier, which is the loudness. But let's have the envelope control the filter. Is that within the envelope, though, or is that the envelope? It is the envelope. It's not within the envelope. Well, there's multiple envelopes, and each envelope controls something different. So this envelope is controlling the loudness. And I'm going to control a different envelope. Let's say envelope number 2 can control my harmonic frequency with the filter. There's different envelopes. So some synthesizers have lots of envelopes. Some synthesizers have like 2 envelopes. It just depends on the synth. So like, for example, Massive can have, I think, 8 envelopes. It depends on the synth. In this case, this synth has 1, 2, 3 envelopes. Yeah, no, totally. And I want you to have a better picture in your head. So we can talk about this, for a second. And envelopes are like, it's really useful to understand envelopes. So here, let me just put the envelope onto this filter here. Now, what I want to do get that to 0. I'm going to turn the filter down. So that's what the sound sounds like now. If I want to put a point of brightness on the beginning of this, what I'm going to do is I'm going to adjust so my frequency is down, and I go here to my envelope. I'm going to turn this up to, let's put it to 5. And you hear how it puts a point on it. And you can hear it if I want the point to be longer. Sorry, hold on, let me. Hold on, I'm gonna mute it while I take a drink. Also sirens. All right, sirens are done. So let's see, Magnolia, you say, so when you bring the level of the envelope up or down, it changes how much the envelope affects the sound. Yes. And that is done right here. Hold on, let me get in here. Boop. Yeah, so here's where your envelope is. And when I make this number a higher number, I think the top number is 16. It's more. And 5 is less. 0 is nothing. And if I wanted to go backwards, I can put negative numbers. Okay, cool. All right, good. Usually though, we don't, I mean not usually, but oftentimes I don't use backwards, I don't use negative numbers. Okay, so now, using this envelope here, I can shape the sound. But what this is doing, and this is important to understand, is it's not shaping the loudness of the sound, it's shaping the harmonic frequencies with the filter. Noli. Okay. All right. So, Noli, please. No, it's super. It is cool. It's so neat. It's like it sounds. You can do all sorts of really cool stuff. And like what I like to do is I like to record this. This is why I prefer to have hardware synthesizers to software synthesizers, because hardware synthesizers oftentimes have knobs for a lot of these parameters. And so I can just grab it and turn things and mess with it, and it works so well. Whereas with software I have to like click around on a mouse and stuff like that. Although I have lots of friends who do, use their mice to do things, and it sounds amazing. But I prefer to grab knobs and stuff like that. So that's one of the reasons why I like hardware. Not because, I mean, it also sounds great, but that's not actually the main reason. But for me, the main reason is just the fun factor. It's hands-on, grab it and turn it and make a sound. And what I do is I often just record stuff for a long time. I just sit there and record stuff over and over and over, like loops and things like that, to make my tracks. Okay, let's go down here and let's see. So that's what's up with that. Now you can also use envelopes to control things like the pitch. Let me go ahead and let's go here and go into this one here and go to the pitch modulation. Now I don't know how many people remember old Diplo or early Afrojack when they had all the samples that were like pitch bent, like that kind of stuff, like the first earliest Afrojack stuff or old Diplo and stuff like that. But what they did was they would take like samples, vocal samples, or the synthesizer and put the pitch bend on the beginning of it. So it would have that, that kind of pitchy. Which is that kind of like pitchy thing. And that was just using filters on the pitch, which is pretty neat. So yeah, RJ, that the hands-on definitely helps the creativity, I think. I mean, just more fun, So that is your envelopes. Now, the next thing let's talk about here is our oscillators, our LFO. LFO, can't you set up the knobs on the keyboard to make it seem like they're... Yes, you can. Yeah, you can. And it takes time, and it works. And it's pretty cool the way it works. And I mean, I need to go through and do it with some things. And some things I've got set up already, and some things I don't. And they work out of the box. but it's still like, I don't know, on the synthesizer, it's just a little bit, it's a slightly different thing, and everybody's got their like hang-ups and what helps them be more creative and stuff. So I like to have that. But yeah, I mean, I totally use software synthesizers all the time. The way I do stuff with them is a slightly different creative process. So I like having a combination. I like having my soft synths and I like having my hardware. I love my Sub 37 synth. I use it for a lot of sound design stuff. And then I use pigments and I use like Omnisphere, a lot of things like that. So I bring in all elements from all over the place. All right, so the low frequency oscillator, LFO, stands for low frequency oscillator. It's just a really slow oscillator. It usually includes the same waveforms as a normal oscillator. For example, sine, triangle, square, saw. And as a matter of fact, if you look at the old Moog synthesizers, Moog modular. Moog modular LFO. Let's see if we can get a, see if we can see a picture of one. That's not what I wanted. Oh, here we go. Yeah, actually, you know what? Duh, what am I doing? I can just show you on Ableton Live. Let's pull up this. Let's pull up modular V3. Boop. Yeah, I don't need a walkthrough. Oh, okay. So here's the Moog modular. Let's go to the templates. One oscillator, one filter. Boop. So let's see. What are you saying? Noli. I once saw my friend use an LFO to randomly change the frequency of a sound. It was never the same twice. I guess that would be modulation. Can you talk about how to do that, or is that just what LFOs do? Basically, yeah, I'm going to totally show you that. Yep. That's basically just what that's what LFOs do. Not always with pitch. All right. So here's this sound. Let's see what this sounds like. Oh, turn that down. Okay. So in here, if we look at our oscillator, you hear that clicking? That clicking means that it's playing so slowly we can't even hear the pitch. And that's what a low frequency oscillator is. It's just a normal oscillator. If I put this back up into regular mode, whoops. And if I just go down enough octaves, right, I can put this, but I can put it so slow that you just can't even hear it. It's too slow. But that's what it does. That's what an LFO is. But that going too slow can actually be used to control things. So it doesn't have to be useless. It's just too slow for us to hear. But remember, this is basically physics, and it's still a waveform that does stuff. It's still like, you know, if you had big enough speakers or whatever, you could feel it pushing against you, pushing the air against you. So what they learned how to do, these engineers, they learned how to harness the power of these oscillators that are going super slow, but they can use them for different things. So what I'm going to do is get rid of that. We're going to go in here to our, let's use analog because it's just easier to use. It's easier to see what's going on, actually. So in here, if I wanted to have my LFO control my filter. So I'm going to go ahead and turn this all the way up, sustain level up. Okay, so what I want to do is I want to have my LFO make it do this. Without me having to do it with my hand on the mouse. That's what I'm going to accomplish right now. So what I do is I go over here, I turn my LFO on. There's my LFO. And I go back into here, and you see where it says frequency modulation. I want to modulate the frequency. So here's frequency modulation, and I just say LFO, how much are you going to modulate it? 4 is the max, so let's put it at 2. And now, turn this down. And now I can go over to my LFO, and I can adjust the rate. So this one here is saying how much it's going to modulate it. And then this one here is saying what my central frequency is. And this is saying how fast. And that's what an LFO does. Different from an envelope, because an envelope is attached to how you play the key. So if I play the key, it has an attack and it has a sustain level, so I can play the key and I can hold it down and it can do that. But an LFO just plays, and it plays a loop with this waveform that you can see right here on the screen. So how do you do it so it's randomized? You just hold on a second. We'll get there. We'll get there. So that's what our LFO does. Now, we can apply this LFO to different things. Right now it's being applied to our filter. I'm going to turn off the filter here, and I'm going to put it on the amplifier so we can make it so it's making it louder and softer. And here are different waveforms. So let's go ahead and use the triangle wave. It's basically the same as our sine wave. And there's also a rectangle wave. And let's turn that off. Oops. And now let's go over here to our pitch. And the pitch, we can have it be modulated by the LFO as well. And now it's doing an octave. So you can do some cool stuff like that. And then, hold on, I'll answer your question in just a second. I can hit this re-trigger button. Now, what the re-trigger button means is that every time I hit a key, it's going to be exactly the same. It starts the LFO every time I hit the key. But if I turn this off, it's different every time. Now, to answer your question you had before about how can we get it to be random, we would use the noise generator for the LFO, or random oscillator. Let's go up an octave. And now it sounds like sci-fi from the 50s. All right. Oh, what's up, dude? Nice. Thank you. I appreciate it. All right, so Noli, to answer your question, would you put an LFO on the LFO? And the answer is absolutely. You can totally put an LFO on the LFO, but it depends on the synth. And this is why you would get certain synths and not get certain synths, or just different synths do different things. They have different strong points. Some of them, the strong point is the routing, and they can do crazy routing. Some synthesizers don't do crazy routing, they just do normal, boring routing, but the oscillator sounds great, or the filter sounds amazing, or you can add your own elements into the oscillator or something like that. So with this synthesizer here, you cannot put an LFO onto the LFO. There's no, it doesn't, I don't see any way to put an LFO on the LFO, not within the synthesizer itself. But if we go look at a different synth, let's pull up a different synth here. We got a couple minutes. We're pretty much done with this section. Let's use Massive. Massive's easy to see what's going on. And it's also a good place to review. Massive. All right, so this is Massive. Okay, first thing I'm going to do is go here to File. I'm going to go to New Sound, and it's going to turn all these oscillators off. So first thing we want to do whenever you're looking at a new synthesizer is you want to kind of look at the synth and figure out what is the structure of the synth. Like, how does the signal flow through the synth? And try to make it as easy as possible. Remember our structure that was right over here. Boom. We have our oscillator, sound from the oscillator goes into the filter, goes into the amplifier. And then you have your LFOs and your envelopes are modulators that are outside of the sound world, okay? Well, we want to see how we can apply that to a new synthesizer. So let's look at Massive here. Just make my screen bigger. Boop. Make it so y'all can see. There we go. I think that's good. Okay. And in here, we want to see, look at this and say, okay, the oscillator section is over here on the left. Cool. And the signal goes from here into our filter right there. Awesome. And then from here, the signal goes into our amplifier, which is just right over here. Great. So just by looking at this, we can say, okay, that's not so complicated actually. What's this section over here? Well, down here is macro controls, like one knob to control multiple things. We have a couple of inserts here. Over here we have some effects. This is like reverbs and delays and phasers and stuff like that. The blue buttons turn things on and off, so I'm going to turn these off. My filter number 2, I don't need it. This here is a balance between filter 1 and filter 2. I'm going to put it all the way to filter 1. Filter 1 doesn't have anything going on right now, so let's put a low pass on it. I'm going to put my cutoff all the way up. I'm going to put my resonance all the way down. Now when we play, cool. Awesome. So that's a polyphonic sound. And I want to make it monophonic, so I'm going to go over here to my oscillator. Is that where I make it monophonic? No, maybe voicing. Okay, voicing max. Let's keep it down to 1. And mono rotate. Legato triller. Great, now it lets me kind of go back and forth. But it's kind of gliding. I don't want it to glide. Turn my glide time down. There we go, so now. So there's my oscillator, there's my sound. This is like a basic sound. Okay, so as you can see in here, we have a whole bunch of things. We have a whole bunch of, there's 4 envelopes and there's all these LFOs. And I can actually change these LFOs to go to, I can change these to be envelopes, I think. Oh no, I can't, okay. So I was saying before, I thought there was 8 envelopes. There's only 4 envelopes, but it's still a lot of envelopes. So now the question was that we were messing around with was, how do we get can we put an LFO on top of an LFO? Or could we put like an envelope on top of an LFO? And the answer is absolutely yes, we can. But before we answer that question, we're going to take a break. This is like a cliffhanger right before a commercial break on a TV show. If you want to know the answer to that question, you're going to have to come back after this commercial break. All right, so yeah, that's what's up. I'll be back in 10 minutes. 10 minutes, I'll be back.